Okay, so in this brief video, I'm simply going to talk about the types of triangles that there are based on side lengths and based on interior angles. So first, let's start with the sides, right? So we'll start with the sides. So if a triangle is equilateral, this means all sides are congruent, right? So for example, triangle one here, if we said it was equilateral, that would mean A would have to be equal to B, would have to be equal to C. All three of these sides, right? A, B, and C would have to be equal in length for it to be considered equilateral. Okay, so if we said isosceles instead, right? Well, we can look at triangles two and three here. Okay, so with triangles two and three, it's implied that two sides are congruent. Okay, so for example, if I'm looking at triangle two here, okay, that would mean if it's isosceles, these two side lengths, A and B, would have to be equal, right? And same idea over here, A and B, we would have to assume would be equal if we're saying that they are both, in fact, isosceles. Okay, last but not least, scaling triangles. Scaling triangles are like the ugly cousin of the other two kinds of triangles based on side length. Scaling triangles simply mean, if it's scaling, that just means no sides are congruent. All three sides are different lengths. So if we look at triangle four here, the ugliest looking one out of the four, right? We clearly see A is not equal to B is not equal to C. None of these are equal in any way, right? They're all different lengths. Okay, so moving on, uh, we also can classify triangles based on their interior angles. Okay, so to get specific, equiangular, okay, this means all interior angles are congruent. Okay, so for example, if we said triangle one here was equiangular, then that would mean theta 1, theta 2, and theta 3 would all be equal. Now, knowing what we know from the previous video, right, all the interior angles always have a sum of 180, like what we saw in the other video, right? Because we know that if all three angles are ever equal, if we do have an equiangular triangle, this would mean that all three angles would have to be 60 degrees or the equivalent in radians, which would be pi over 3 radians. Okay. Um, Depending on where you're at, I may not have covered radians yet, so not going to go too far into that. But that means anytime I have an equiangular triangle, all three angles must be 60 degrees. Okay, so on that same note, we can also imply that because all three angles are equal, right, that means all three sides must be equal. Okay, so this means equilateral and equiangular are the same thing. Okay, so equiangular and equilateral, if it's equiangular, then it's equilateral. And if it's equilateral, it must be equiangular. So if all three angles are the same, all three side lengths must be the same. Okay, that brings us into the next kind of triangle that we should be pretty familiar with already, what we call right triangles. They have a 90-degree interior angle. And you'll hear me just say a 90-degree vertex for short. Okay, that just means, well, obviously we've got this right here. Okay, so triangle four right here is obviously a right triangle because of this 90-degree vertex that we see here. Okay, so any triangle that has a 90-degree vertex, we can call it a right triangle. Okay, acute triangles, the interior angles are all less than 90 degrees, meaning they're all acute. Okay, so triangle 3, we see we have, this guy's obviously acute, this guy's obviously acute. However, theta 3 here, well, that's greater than 90, right? Triangle 4, well, we've got an angle precisely equal to 90. Okay, well, we said less than 90. So that means triangle 2 is my only acute angle here. We see that theta 1, theta 2, and theta 3 are all less than 90 degrees, right? So because theta 1 is less than 90, theta 2 is less than 90, and theta 3 is less than 90, okay? This means it is acute. Okay, and last but not least, obtuse triangles. Okay, they have a vertex or interior angle that is greater than 90 degrees. Okay, and we see triangle 3 here, obviously. This theta 3 here, right? This guy, theta 3, is obviously greater than 90. So that means triangle 3 must be obtuse. Okay, so that does it for this video. These were the types of triangles based either on the side lengths or the interior angles. If you have any questions over these triangle facts, obviously shoot me an email. Otherwise, you know where to find me. Goodbye.